Welcome to this video on question number 4. We are solving past paper question in these set of videos. This is your AS Physics past paper question on the topic dynamics, Newton's laws of motion. So here is your question. This is the first screen of your question. If you want, you can take the snapshot of the screen, try to solve the question yourself, or you can pause the video, try to solve the question yourself. We have this question split across two screens. This is the second screen of the question. Once you have solved the first screen, you can solve the second screen and then play the video to look at the working of this question as well as to look at the mark scheme for this question. In the meantime, while you are solving, please take out a moment to subscribe to the channel because your subscription is highly rewarding and highly encouraging for me to keep making good quality videos for my students. Alright, so here we are. I hope you are back now. You have solved the question, you are playing back the video. So let us understand what is happening in the question. Let us start with part A. A sphere of radius r is moving through a fluid with a constant speed v. There is a frictional force acting on the sphere which is given by the expression. The formula for the frictional force they have given here, or the expression which defines the frictional force is given here, where d depends on the liquid. D is a factor which depends on the fluid. Show that the SI base unit for d is kg per meter per second. So they are telling you to derive the unit of the quantity d. So how do you find d? Now this is a question which is not so difficult to do, and I am sure that many of the students know how to do this question. So we start with copying the same formula here. So F is equal to 6 pi d r v. Let us write this whole expression in terms of d. So d is equal to F over 2 pi, sorry, it's 6 pi, my mistake, F over 6 pi, this is r, my mistake, r v. Alright, this whole equation can be written in this way. Now let us write down the units for each of these terms. Force has a unit of newtons. I am writing everything in brackets because these are not numbers, these are units. 6 and pi will not have any units because they are numbers, they are constant numbers. R, what is r? Let us see. R is the radius. Radius is a measurement, is a length, so it will have a unit of meters. And what is v? V is a speed. The unit for speed is meters per second. Now what is the unit? We have to define everything in SI base unit. How can you simplify the unit for newtons? Let us write the formula for force. We know that Newton is a unit for force. So is there any formula for the force that you know of? Any formula for the force that you know of in very simple terms? MA is a simple formula. So what is the unit for mass? Kg. What is the unit for acceleration? Meters per second square. So that's the unit for force in terms of the SI base unit. Whenever you have to find the unit of any particular quantity in SI base unit, you should know some of their formulas. You can use any of the formula for the force. One of the formula that is very clear is MA, right? So we used it to find the SI base unit for force. So Newton here can be changed with this term kg meters. Second square will go in the denominator, second square, and in the denominator you already had meter, and one more meter you had over second. So this second will go up in the numerators. This is simple maths into seconds. Let us strike out the values. Let's put everything in brackets. Meter and meter will strike out. One of the seconds will go away with this power of 2, right? So what do you get? kg over second times meter. So this whole thing is kg meter to the power minus 1 second to the power minus 1. So that's how you solve these questions. It took some time. It takes time generally, but they are easy and straightforward. And it's a 3-mark question. If you can solve this, you get 3 straight marks. If you want me to practice more questions like this to derive the SI base units for quantities, let me know. I'll make more videos on it. Please do type in the comment box and let me know. A raindrop, I'm on the second question now. A raindrop of radius 1.5 mm, please keep taking note of the units as well, falls vertically in air at a velocity of 3.7 meters per second. The value of d for the air is given to you and the density of the water is also given to you. Calculate the magnitude of the frictional force. Use this formula, it is already given to you. Substitute all the values. So F is 6 times pi, which is 3.14, times d, it's given to you 6.6 times 10 to the power minus 4 times r, what is radius? 1.5 millimeters, so 10 to the power minus 3 meters, right? This thing is equal to this, times v. How much is the velocity? 3.7. Now this is a question, easy question, so it is a 1-mark question. All you have to do is to use your calculator, multiply the numbers and see if you're getting the answer as this. 6.9 times 10 to the power minus 5. You need not worry about the unit. Unit is already mentioned here in the question, right? Force is done, frictional force is done. Now they are saying the acceleration of the raindrop. You have to find the acceleration of the raindrop. It is a 3-mark question again. So already this question is 3 plus 3 plus 1, 5 marks, and there are more parts to it. So that means a lot of marks to be gained or to be worked on to get this right? Acceleration. How do you find the acceleration? Let us draw a raindrop. Let me draw a blue raindrop. Alright, so what are the forces acting on this raindrop? There is a weight acting downwards. Let me use the red color to draw the forces. So the weight is acting downwards. And is there any other force acting on the raindrop? Yes, it is very clearly mentioned that there is a force of friction, which they are calling as F, but we'll call it Fri for simplicity's sake, right? So you're given the 2 forces, but the frictional force has to be lesser, right? Because the object always moves in the direction of the greater force. The raindrop is moving downwards. The raindrop always moves downwards, right? So that means weight has to be bigger as compared to the friction. So let us draw a smaller arrow for friction and a bigger arrow for the weight. So what is the resultant force acting on this water droplet? Weight minus friction. And what is the formula for the resultant force in terms of acceleration? Because you have to ultimately find acceleration. Resultant force is always ma. So let us substitute the values. ma is equal to mg. Weight is mg. The formula for the weight is mg minus the frictional force is how much? This thing. Frictional forces, they are calling it as F. So acceleration would be, let us substitute the values. M is how much? Mass. Okay, so now you have to find the mass also. Mass is not given, but you are given the density. You are given the density, right? So if you know the density, you know the radius, can you find the mass? Can you find the mass? Yes, you can. You'll have to use, it's a slightly lot of lengthy calculations involved. So let me erase and make some space here. Let me erase this working because you've already seen. Let me make some space. The formula for density is, the density is given as rho mass over volume. So mass is what? Density times volume. So why are we using the density formula to find the mass? Because we are given the value of the density. It should give you a hint that we are going to use the density formula for finding the mass. We are given the density and we are also given the radius. So radius means you can find the volume, right? The volume for a sphere is 4 by 3 pi r cube. A lot of calculations involved here. So input the values. The density is 1000. The number comes from here. Times 4 by 3. Pi we know is 3.14. R is, how much is the radius? 1.5 times 10 to the power minus 3. The whole cube. This will give you the mass. Lot of calculations you'll have to do to find the mass, but a lot of calculations, but they are not difficult calculations. All you have to do is to use your calculator and you'll find the value of mass. Let us see what is the value of mass. You can pause the screen, do this calculation, find the value of mass and see if you're getting the answer as, they are saying that the mass, they are not finding the actual value ultimately till the very end, but ultimately when you substitute all the values in this equation, substitute the value of mass here, right? Work it out, substitute the value of mass times 9.81 minus the frictional force is how much? 6.9 times 10 to the power minus 5 over mass again, over mass again. Solve it. Your acceleration should be 4.9 meters per second square. Lengthy calculation, lot of calculations, so be careful while using your calculators. You should be, if you're inputting the values correct, you should get your answer correct. So what are we doing here? We are finding the resultant force. Let me summarize. We are finding the resultant force. We are using the formula for the resultant force, which is MA, to create an equation like this. MA is equal to mg minus F, which is frictional force. M is quite a lengthy process to find out, but not difficult. It comes from the density formula. Substitute the values and you will get the value of M. Input the values in the equation and you will get the value of acceleration. So let us move on to the next part. The variation with the time t of the speed v of the raindrop is shown here. Velocity versus time. State the variation with time t of the acceleration of the raindrop. Now whenever you look at a graph which looks something like this, you should immediately think about it that we are talking about terminal velocity here. A velocity time graph which starts as a straight line, takes a curve and becomes flat, means that there is something happening with respect to terminal velocity. So what do you say? Initially when the raindrop started falling down, the only force acting on it was mg, because it had initially taken a drop. So the velocity was 0. It started from rest. The velocity was 0. It just took a drop. The only force acting on it was mg. Velocity was 0. Will there be any air resistance when the velocity is 0? No. Whenever the velocity is 0, air resistance is 0. After some time it reached down. The velocity was not 0 anymore. So there will be air resistance as well. Air resistance, velocity is not 0. So there will be some air resistance now. There will be some air resistance. Ultimately, because mg is greater than air resistance, so The raindrop will keep moving in the direction of the greater force, and the speed will keep increasing ultimately when mg becomes equal to AR. Now if you see, I have drawn both the arrows of the same length. Earlier AR was smaller as compared to mg. So what happens? The resultant force mg minus AR, air resistance is 0. Why? Because mg is equal to AR in this situation. So resultant force becomes 0. That means acceleration becomes 0. Why? Why? Because the resultant force, the formula is ma. So if the resultant force itself is 0, so the acceleration has to be, let me simplify it. So acceleration is resultant force over m. When the resultant force becomes 0, acceleration becomes 0. In this part, the acceleration has become 0. That means it is not increasing any speed. It is not a case of decreasing speed. It is a case of constant speed. So initially your acceleration was g. The resultant force in the first situation, second situation, and the third situation. In the first situation, the resultant force was ma. That's the formula, which is the resultant force was mg. So what does it mean? Acceleration was g. When it just took a drop, the acceleration initially when it just took a drop, the formula for resultant force is ma. And if you look at the situation here, the resultant force is only mg because there is no upward force. So that means acceleration is g. Second case, how much is the resultant force? Again it is ma. The formula for resultant force is ma, but now it is mg minus air resistance, right? Resultant force, which is ma, is mg minus air resistance. What has happened? The g value has gone down than, a value has gone down than g. Acceleration has decreased here. Acceleration has decreased because the resultant force on the object has decreased. Resultant force was mg, it is now decreased by air resistance. Resultant force whenever decreases, resultant force has gone down. Resultant force has gone down, look here. So acceleration will go down, and ultimately at the third location, resultant force is again ma. Always the formula for resultant force is ma is 0. So that means acceleration is 0. If you do not understand how to answer this question, please go through my video on terminal velocity. It will talk about these things in great details. The video is already uploaded on my YouTube channel. Go through it. This is a clear case of how acceleration varies whenever the terminal velocity is achieved. Initially the acceleration for free fall would be g. Then the g is decreasing. In this case where there is a downward curve, g is decreasing, and then where there is a flat line, g becomes a becomes acceleration becomes equal to 0. Right? The third part, a second raindrop has a radius which is smaller than that given in question part A. On this figure sketch the variation of the speed with time t for the second raindrop. So when the mass is smaller, size is smaller means mass is smaller. You'll achieve at a terminal velocity much quicker. You'll achieve the terminal velocity much quicker. If you see, you are achieving a terminal velocity at a smaller period of time as compared to this, which is a bigger period of time. Look at the values on the y-axis, on the x-axis. You are achieving the terminal velocity at a greater value of t. Here you are achieving a terminal velocity at a smaller value of t, and also the magnitude of the terminal velocity will go down. Here the magnitude of the terminal velocity was a larger magnitude. Here the magnitude of the terminal velocity as well has gone down. The magnitude of the terminal velocity also goes down. Compare these two numbers. So your final answer should be a curve like this, which I am tracing with my pointer. So please do have a look at the mark scheme to look at the answer as well. It is the same answer, right? Even for the next part, same answer. Going through the mark scheme is very, very relevant, very, very important to understand the questions completely. And for the terminal velocity question, the students who are facing problem on understanding this particular question, I would request go through my video. I would again and again request go through my video on terminal velocity, because questions on terminal velocity are very common. It is slightly a technical topic to understand, but when you go through the video, it will make all perfect sense, because I have made the video very nicely in a step-by-step process. Alright, so stay tuned, stay connected for question number 5 on the practice questions of AS Physics Dynamics. Equations of motions, Newton's laws of motion.